Thank you, Catherine. Welcome again. Let me add to Catherine's welcome. This is the Nardone seminar series and the first event in that series in the fall. And I'm absolutely delighted we have a cutting edge topic, and we have Professor Vinod Jain joining us today. Very briefly, Vinod has a very distinguished professional and academic career behind him. And the talk he's about to give is based on his latest book, which is titled Global Meets Digital. And then the subtitle is very interesting. It reads, Global Strategy for Digital Businesses and Digital Strategy for Global Businesses. So it's really coming together of these two very important topics that he's going to talk to us about. He's an expert, as you can tell from the title of his book, on both global and digital strategy. He's a Fulbright scholar. He taught for a number of years at the University of Maryland. He now is speaking to us from just outside the Washington, D.C. area. And he's going to talk to us for about 40 minutes based on this, all the research he did for his book. And that should leave us about 30 minutes for Q&A. So if you have any questions, as Catherine said, please post them on chat, or if the group is small enough, we may be able to get you to ask the question directly. So with that, welcome, Vinod. Great to see you, and over to you.
Hey, thank you, Ravi. It's very kind of you to invite me. I'm really honored to be speaking to your group. Oh, here's my screen. Okay. Well, I have been fascinated by technology really all my professional life. Well, not all my professional, only the last 30 years or so. And I'm going to talk to some of the excitements I have come across today. Let's see if I can keep going. Yeah. So this is what I'm going to talk about. I don't want to read through this. The theme is how the industrial Internet of Things changed manufacturing, and I use the word forever to keep it exciting. I don't know how many of you have actually gone through a shop floor with machines and all. I know one of my friends here, he used to manage a major company with all kinds of machines. Anyway, so let's continue. First, a little bit about me. And rather than read through this, let me share my professional journey with you, which has included at least 4 major areas. I started my career, professional career, as a statistician, or studied statistics, though I never worked as a statistician. Then I did marketing research for Coca-Cola, did my MS in management and marketing. So from statistics to marketing, then to strategy, where I did my PhD at the University of Coca-Cola. And then to global strategy, where I wrote a book, and I'm going to show you what book it was. And I taught global strategy for 10 years at Maryland. And my latest love is digital strategy. And the fact that I'm saying latest love, I actually have been in this, interested in digital business, digital strategy since the late 90s, at the height of the .com work. I registered my first domain name, business domain name, in 1998, when I also launched an internet company, which lasted 2-3 years until the .com bust. Anyway, I have been interested in this field, and which led me to write a book on this topic. So that's my current book, published just in June this year. And some of what I'm going to talk about is contained in 2 pages of the book. This was my global strategy book, published 2016. It's like an MBA textbook. I have used it in my MBA classes, and I know some other universities use it too. I know that because I get a royalty check twice a year from the publisher. A long time ago, my wife and I wrote a research monograph on how America benefits from economic engagement with India. It was done on behalf of the Federation of Indian Chambers of Commerce and Industry, and also funded by Smith School. They gave me a research assistant, and so on. Anyway, this is sort of my professional journey. Let's start. I mentioned in the brochure for this Nardone seminar about the 4 industrial revolutions. I don't need to talk about that. We are currently in what has been known as the 4th industrial revolution, or Industry 4.0. That's the focus of our conversation today. The term was actually coined by the CEO of the World Economic Forum, and he defined Industry 4.0 as the digitalization of industry, which began a long time ago, but with certain characteristics. And look at this slide. It has all of these things it covers: cloud computing, mobile devices, IoT, Internet of Things, 3D printing, and so on, all kinds of things. We'll have a chance to talk about some of these things today. Okay, let's go through this, the 4th industrial revolution, or it's also been called Industry 4.0. It entails reimagining business, utilizing digital technologies and digital business models. Now, if you know what manufacturing used to be like, I'm not thinking of smokestack industries, but even just last year or right now, I mean, we even have robotics in industries, in manufacturing companies. We have CNC machines, computerized numerically controlled machines, which actually we have had for like 40 years, at least 40 years. That is when I first saw them. But the 4th industrial revolution, or Industry 4.0, has something else. We're going to be talking about what the basic thing it has are the Internet of Things, or in products which are both digital and physical and connected to the internet, and what all they can do. So as part of this Industry 4.0, we see that lines between manufacturing and services are blurring. Companies that used to sell products now don't sell products, but give them out on a monthly subscription. So the ownership of the product, of the equipment, stays with the manufacturer, and they undertake to make it completely error-free and so on for a monthly subscription. This is an incredible business model, and I'm going to talk about it quite a bit. I mean, Rolls-Royce, for instance, not only sells engines, but they also do service, maintenance, repair, and service, which is a very, very major earning opportunity for Rolls-Royce. But lately, they have started giving the service in a very special way. They say selling service by the hour. Rolls-Royce gets paid for the actual number of hours the plane is flying, the engine is flying. It's a very special business model that they are using. Michelin has started using IoT in their tires. So instead of selling tires, Michelin has been charging customers for the number of miles a tire actually drives. So IoTs and the digital products have special economic characteristics. Now, a digital product, let's say Microsoft Office 2000, now it's of course 2020, it probably cost Microsoft billions of dollars to bring it to its current level over a number of iterations. Now, to provide another copy of the software, what does it cost them? Nothing. It's a digital product. And shipping it to you on the internet is also zero. Cost is zero. So basically, for digital products, there's a zero marginal cost, the cost of an additional copy for production and distribution, which is very different from physical goods. And they also benefit from what is called network effects. The more the number of users, the greater the benefit they get. So Industry 4.0 usually refers to the use of digital technologies to transform how industrial companies operate. Technologies like artificial intelligence, data analytics, cloud computing, 3D printing, robotics, cloud computing, digital twins, and the industrial Internet of Things are used. Now, incidentally, I'm coming at it as a strategist, not as a techie. I can probably describe all these things, but I cannot code. So that's the difference. So Industry 4.0 is where the physical, the digital, and the virtual worlds merge. It makes everything in your supply chain smart. When I say smart, it means it makes them intelligent. And that comes from sensors embedded into the physical goods. So anytime you hear of a smart home or a smartphone or anything smart, you're really talking about a product, a physical product, which has sensors and technology embedded into it so that it can do things even without human intervention. So those sensors, or what is industrial Internet of Things, gives a company unprecedented level of visibility and control over operations, which is really the crux of Industry 4.0. And it makes autonomous systems possible. When I have a HP printer at home, like most of you have, and I never run short of ink, printer ink. I pay them a monthly subscription fee, and they know they know how much I'm using it. Every month or every other month or whenever I need, they ship me ink for my printer. That's done through the Industry 4.0 type of activity. So this is how I would describe physical meets digital, which is the title of my book also. On the left side, you see the physical world consisting of physical goods, plant and machinery, the glass of water I'm drinking from, anything physical which you can touch and feel. And then there is digital, such as software, ebooks, all kinds of digital goods that are available in the market. And digital goods, as I mentioned, have this zero marginal cost characteristic. And then at the intersection of the two, that is physical and digital, these are products that are physical and digital and connected to the internet. Think of it. Do you have any Internet of Things at your home or with you now? What about an Apple Watch? Even the smartphone? security system at home, all kinds of things would fall into this category, physical and digital and connected to the internet. It's also known as the Internet of Things, or smart machines, or intelligent machines. Much of our conversation today is going to be about Internet of Things, products that are physical and digital and connected to the internet. And there are literally millions of them, not millions, billions of them around us. I just looked at the number of IoT devices, Internet of Things devices in the world today. That's like, I think the current estimate is about 15 billion of them as of 2023, going to be more than double by 2030. They are increasing it exponentially. All right, let's talk about more specifically. Internet of Things, or IoT, are goods that are physical and digital and connected to the internet so that they can communicate with other connected devices over the internet. They have the ability to act independently of human intervention. And the things is what we mean by products. The network of physical objects or things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. That's an Oracle definition. And IoT devices at home, smart thermostats, doorbells, security cameras, digital assistants, connected home appliances, Apple Watch. What about the iPhone? It's physical and digital and connected to the internet. So is it an IoT device? Well, there's some controversy about that. The purists say it's not an IoT device by itself. It's the apps in the iPhone which make it do things independently of human intervention. Anyway. So what is this new thing called IIoT, or Industrial Internet of Things? I would think of IIoT as a subset of IoT on the right side. Except that they are typically devices in industries, on oil rigs, in energy plants, and so on. I'm going to give you several examples. So the Industrial Internet of Things are connected devices. Connected means they're connected to the internet, often in high-stakes industries like oil and gas, machinery, power generation, etc., where unplanned equipment failure can be very costly, even life-threatening. Now, if my iPhone fails, my life is not threatened, though some people may feel so. But if an equipment in the oil field fails, it can really cost them millions of dollars to repair it and cause other problems. So these IIoT devices, they are machines that operate semi-independently with minimal human intervention, responding intelligently in real time to changes based on information captured, and thus reducing the cost and risk of human error. So if something is happening on a rig, oil rig, if a problem were to occur, earlier we had to send somebody there to go and check it out. But if the rig has those sensors embedded into it, then somebody sitting on an office would know what's happening and could possibly even send instructions back to the rig about how it can be corrected. So IIoT is generally used for business to business applications, and IoT is for B2C applications, where if something were to fail, it's not going to be too serious a problem. Oh, so in 2022, the number of IoT devices, including IIoT, was 13.14 billion. And by 2030, the estimate will be 29.42 billion. By the way, I'm not giving any references like scholars do. This is a professional event. Much of the data, much of what I'm talking is actually in my book. And if anybody is interested in some specific thing, please ask in the Q&A area. I'll be happy to provide citations. The IIoT involves the use of smart sensors, actuators, and other devices, such as RFID tags, GPS, etc., to enhance manufacturing and industrial processes. And these devices are networked together to provide data collection, exchange, analytics, exchange and analysis. Insights gained from the process can lead to greater efficiency and reliability. And typically, such data becomes available on a single dashboard. What is happening earlier, there may be many dashboards, not just one dashboard. But now, generally, there's a single dashboard which can have everything. The sensors used in IIoT are more precise than those used in IoT, and also they're more costly. They can be very, very tiny, such as environmental sensors, or very complex, such as industrial robots. Let's go into the subject matter of today, how the IoT changes manufacturing. So there are several categories, as I mentioned. Asset monitoring is one of them. It's actually the most common use of IIoT in industry. Monitoring remote industrial assets from a centralized location or from a smartphone. Assets are embedded with sensors, software, and technologies, and these could be tires on a Michelin truck or a Michelin tire on a truck. These could be wagons being loaded, unloaded in trucks. These could be machines, anything. Those are the kinds of assets when they have sensors attached to them, they can be monitored. So there are two kinds of monitoring. What is read-only, in other words, you can get information from it, but you cannot send instructions back to it. And the other is read and write, where you can not only read what is happening, but also write back to it and exert some control over that. So any data that comes in is transmitted to the cloud, accessed by the cloud of the company where the data are collected, and passed on a dashboard in a centralized location, or even on a smartphone. There are some couple of examples. I live in Loudoun County in Northern Virginia, and we get water from Loudoun Water. Last few years, they installed 78,000 smart water meters. Smart means they have sensors embedded into them. And through that, they can capture the meter data in real time regarding water usage, leakage, saving millions of gallons of water with accurate billing without anyone visiting home. In the past, somebody used to come to the home every month to read the meter. Now they don't have to. It is all, and not only the utility, I as a customer also have access to this. I've never tried that, but I can go back to Loudon Water and find access to my own water meter and see how I'm using water. Surprisingly, a few years ago, we were in China for a year, and I got an email from Loudon Water that there's some excess water leakage in the house. Could you please go and check? Well, I was in China, so I couldn't go and check. Our daughter lived in the area. I asked her. She went back to the house, and sure enough, she found that one toilet was just running. It would not stop. It was a minor thing. So she just made it okay. The smart meters also eliminate human error. No one has to visit the site, offers real-time insights to the utility and the consumers on water consumption. Another example from India, Pune, India, Coca-Cola bottling company, they do asset monitoring for their PET and can bottling lines to continuously measure syrup flow rates, water temperature, and so on. So this data comes to them, which they can see how the bottling lines are working. And they also set up some kind of an exception reporting. If the temperature goes too high or too low, or if there's a problem with syrup flow, it'll generate an alarm based on some predefined criteria. Now, this is asset monitoring and control, read and write. In other words, you not only get the data, but you can also send instructions back to the asset with whatever is needed. An example, Schlumberger, a US-based oil field services company, in fact, is the world's largest oil field services company, has operations in 120 countries. They've installed permanent sensors in downhole tools and surface equipment on their rigs, which continually transmit data to centralized remote monitoring centers. The data about all kinds of measures that they should be concerned about on their oil wells. Use a remote monitoring and control for oil flow assurance, asset integrity, and optimized production. Helps them avoid employees having to go to dangerous environments. So no employee has to go to the rig to find out what actually is happening there. They already know it. They also have many other IIoT applications, such as predictive maintenance, well production optimization, reservoir surveillance, and safety and environmental monitoring. Another example is vehicle fleet management. Now, Linneas is a private freight carrier, rail freight operator in Europe, and they've got these wagons going from country to country, from city to city. So they are using an IIoT-based track and trace cross-border fleet management system from Bosch, a German company, for all 2,600 wagons. So the sensors provide information in real time on where the wagons are located, which routes can be optimized, and where longer standstill times are occurring. All important information, which otherwise they probably would not have been able to get. So it helped them increase their capacity utilization by over 40% within the first year. They can better plan the routes. and they can communicate the expected time of arrival and possible delays to clients in real time, helping them better plan their loading, unloading, and other operations. Another example, this is from my book, the Suzhou Construction Machinery Company Group in China. That's China's largest construction equipment manufacturing company. They make cranes and other large, huge machines, and the world's fifth largest heavy machinery company. There are 14 manufacturing and assembly plants worldwide and exports to 180 countries and regions. So what they've done, this is quite incredible. They have developed their own cloud platform called Xria. In 2009, my information is up to 2019, Xria was serving more than 1,000 industrial enterprises in 20 countries in 63 industries. By then, over 760,000 pieces of equipment worldwide had sensors embedded into them, and they were connected to the Xria platform. In other words, all the data from those sensors was being fed to the Xria platform, where it would be analyzed and they would do whatever is needed. So once a piece of equipment is connected to the Xria platform, it can be remotely diagnosed and maintained without human intervention. It was monitoring equipment location, operational status, predicted timing of equipment failure, and more, based on data collected from the sensors, IoT terminals, enterprise information systems, and then analyzed at the platform. I mean, this is really, really quite powerful. And even though I'm calling it Industry 4.0, these guys have been doing it since mid-2010s. And so many other companies. Now, if you have a software update on your iPhone or another smartphone, or if your car has software, most cars today have software embedded into them. If needs an update, you don't need to take it to the dealership. The companies are able to do the remote software updates from back home, wherever they are based. Preventive maintenance is a major application of the IIoT. Preventive maintenance is basically when equipment maintenance is to be done, you want to do it ahead of time on a schedule so that there is no work stoppage and extra cost. Sensors embedded in industrial equipment monitor equipment performance continuously, remotely, and act autonomously if a problem is detected. They could trigger a service request or even correct the problem if it is a minor problem. And subsequent data analytics can be used for predictive maintenance to detect potential issues before they arise. Now, many companies now do predictive maintenance. I was just reading that Embraer from Brazil has outfitted its executive jets with predictive maintenance software so that they could perform predictive maintenance before any serious problem arises. So it uses sensors and cameras in IoT equipment. Subsequent data analytics allow machines to predict failure before it occurs. An example, Colgate-Palmolive company, we all use toothpaste from there, installed sensors in 2,000 machines, such as toothpaste tube makers and toothpaste liquid machines, to collect operational data in real time. They use the predictive maintenance system for a company called Agori, which uses sensors to monitor machine vibration and detect potential problems by comparing such data with a database of vibration data gathered from other locations. So the system was piloted at one of Colgate's manufacturing plants in Pennsylvania, and it avoided $60,000 in downtime cost. In other words, unplanned downtime can really cost a company production and additional cost. It was able to generate guidance and to when to do the maintenance. Now it's used at a lot of Colgate Palmolive factories worldwide. Solar Now is a Ugandan solar equipment energy company, and they were concerned about disruptive, malicious, and costly service interruptions for remotely deployed solar equipment. They implemented a predictive security management service provided by Amazon's AWS IoT, that's Amazon Cloud. They have a service called IoT Device Defender, which monitors normal behavior of the devices. And if they find an anomaly, it triggers further action. So what I'm trying to say is, it's not only the world's largest companies or the advanced countries. Emerging markets are beginning to use them, but not as much as advanced countries are doing. On a Google search, I found many examples from emerging markets and developing countries where they are beginning to use IIoT for manufacturing processes. Now, automatic fulfillment. I started by giving the example about ink sent to me by HP automatically. I mean, they have a system to know how much paper I'm printing, because my printer is a connected printer, and they automatically send me inks as I need, and not just a whole package, but they could send me just the cayenne ink if that's the one finishing earlier. Another interesting example I found, in an industrial plant, they keep their supplies in bins, and a worker has to go to the bin to pick up what he or she needs. Now, there's something called smart bins, which uses weight sensors under the bin, which continually knows what's the weight of products in the bin. So if a bin contains, let's say, whatever product, fasteners, for instance, so from weight they know what is the quantity of fasteners left in the bin. Once the weight, and these checks are made several times during the day. So once the quantity falls below a certain amount, the smart bin would issue a reorder right away. No individual has to go and check it out. So replenishment happens continually, with the result that there are no stockouts. Production would not have to stop. Similarly, you could do compliance monitoring. I'm running short of time, but anyway, FaceMe is a facial recognition product that can monitor and enforce work safety standards. During COVID-19, it was checking whether a person was wearing his face mask properly. Caterpillar has connected helmets, which can detect hazardous and unsafe working conditions in the field. Helmets have smart cameras embedded in them. Now, quality control obviously can also be done. IIoT sensors can be used in production processes to detect defects in real time, allowing the manufacturer to make adjustments before defectives are produced. But here's the interesting example I saw. Coca-Cola, okay. Schwering and Hess, a magnet wire maker, utilizes IIoT to monitor and control the quality of daily production. They make 14,000 kilometers of high-grade copper wire every day across 400 production lines with 20 different types of sensors and 20,000 fully automated delivery pallet slots. It monitors 50,000 production data points per second and analyzes it for quality assurance down to an inch. Can you just believe that? I mean, imagine if it had to be done manually. It's just impossible to do such a thing manually, or even 10% of that. Quality control on 14,000 kilometers of wire every day, down to an inch. Wow. Finally, all of this excitement has developed new business models. Companies can use new business models rather than the old model. And a model that I'm very excited about is product as a service business model. It's based on the idea that customers really want access to equipment. They don't necessarily need to own the equipment. If they need to buy certain equipment, well, it's a big capital expenditure. Why don't I just take the equipment on a monthly subscription? So my capital expenditure becomes an operating expenditure. And not only that, under this model, the company which gives out its equipment as product as a service, the company retains ownership of the equipment. They agree to maintain it in perfect working condition and just get a monthly or annual subscription fee. It transfers the company's risk of big capital expenditure to the manufacturer, but with guaranteed equipment performance and paying a monthly or annual subscription fee. You think of it as an outcome-based business model. A lot of companies are already using it. I'll give you a couple of examples. Xerox now offers its customers a Xerox all-in plan. A customer can get a printer on a 36-month lease, plus full maintenance and automatic supply replenishment at a monthly cost of $59 per month for small business. Print volume is limited by the printer model selected. So instead of buying a costly Xerox printer, you could just have access to it to do what you need to do. And by the way, today, many of these luxury car models are available not on lease, but on product as a service model. Audi, for instance, you could get an Audi at a monthly subscription price, and they can maintain it for you. It's not leasing, because in leasing, you maintain it yourself. Under the product as a service model, Audi would maintain it. You just have use of the car for a monthly subscription fee, so long as you keep it for a certain number of months. Another interesting example is Kaiser Kompressoren from Germany, a leading manufacturer of compressed air products used by industries to transfer energy in industrial processes. For instance, when you need to restart something, you would need energy for that. So Kaiser offered to customers on subscription with guaranteed uninterrupted compressed air as and when needed, with the customer paying only the air actually used. So the equipment is owned by Kaiser. They install it at customer premises, and monitor the compressed air stations around the clock, and services it as needed. Kaiser owns, installs, and maintains the equipment at customer premises, assuming the risk of ownership. The customer gets the compressed air as and when needed and pays only for what is needed. Okay, anyway, I think I'm run out of time. So why don't I stop? Oh, by the way, this is my book. I need to take a minute to promote my book. It's available at all online booksellers. Anyway, let's stop here and see if there are any questions. Thank you very much.
Thank you, Vinod. We do have a few questions, and I'm going to ask the people who post the questions to ask it themselves. But before we go there, I just wanted to suggest, at least as a hypothesis, that IIoT should be really big in China. But I know that China is hard to research, and we nowadays even become harder to get information on what is happening on the ground. But we know that China is the manufacturing leader or industrial leader, and also has put a lot, is leading in 5G, which is, I think, the foundation for some of the connectivity of these devices as they go up in numbers, and also very much targeting IoT, all of the things you mentioned, 3D printing, robotics, AI, are all sectors in which are priority sectors in China. So I would be surprised if they're not, in fact, doing many innovative things. But I agree, I understand it's not easy to get information on what's happening, the latest things, practices in China. Any comment on that before we invite someone?
Yeah, the case study that I used, XCMG, the Suzhou construction machinery company from Suzhou, a beautiful city I've actually visited. That is from a case study written by a friend of mine from IMD. And they allowed me to use it in the book also. But you're right, it's very hard to get more accurate information or more information.
Mm-hmm.
I know Alibaba, Hire, they're all doing a lot of IIoT work.
Yeah. Okay, let's take a question from Subhash. I think he had the first question. Subhash, if you're there, can you turn on your mic, and if you would like the video as well, if you'd like, and just ask the question yourself.
Well, I'm not putting on video because I'm not looking as stunning as the rest of you. But okay. certainly ask a question of Vinod. I have actually two questions and one quick comment. But the question is, how would the Internet of Things and digital strategy affect traditional models? I mean, traditional models of competitive advantage, such as Michael Porter's. So that is my first question. And quickly, the other one is that going beyond diagnostics in industrial equipment, such as engines you mentioned, Vinod, through IoT, could the advent of artificial intelligence provide maintenance on the fly?
Well, Subhash, you asked a question like an engineer, which I know you are a great engineer. Just by the background, I worked for him in a cigarette machinery maker company back in the 80s and learned a lot from Subhash. Now, the traditional business models suggested by Michael Porter would not at all apply here. I hate to say this because I'm a fan of Michael Porter. That was a long time ago. He designed these things in the late 70s and 80s. And even by 2000s, some of what he suggested was not really going to be that much applicable. And I've taught his material for 25 years. The other question, I really need to think hard about it because I'm not an engineer. I'm a strategist. Okay. I don't know if that is satisfactory to you.
Okay, let's leave it at that for now. We can come back to it. Maybe if Subhash has any follow-ups. Otherwise, I'd like to ask Hasmukh Shah, who, after long absence, is back with us attending our events. Hasmukh, welcome back. And would you like to ask your question?
Absolutely. Well, so I'm not a strategist. I'm an engineer by training, but I'm a widget maker for many years. So when I beg to differ with where the IoT is going, and I think what we generally are missing is what it takes to support it, how to install it, what it takes to program. So what we take it for granted as something very simple is very complicated. Try to install a IoT system in your house. It's a great idea, right? You walk in the house, you can turn on all the lights, you can have a group of lights that come on, turn on when you want it, but try to program it. Ask your local electrician or a large contractor to program it. And then ask when the system fails, how are you going to turn on the lights in the house? And then if you have to reprogram it, what does it take? So one of the mistakes and this I've heard it all my life, factory automation. And the people who made the money are the ones who sold tools. So this is where the lots of money is to be. So if you want to be in IoT business, sell tools. In terms of, there will be, so I look at this as an incremental technology. It will have places where it will be useful. But otherwise, this is not going to be a game changer. And so anyway, that is the point I would make. So, but this is not Dr. Jain's, I think, presentation. It is that if it is successful, I think that there is going to be a huge opportunity. So my point is not on strategy, but I don't think this technology is going to be as impactful as we all believe.
Can I just ask Hasmukh, have you tried to use this in your operations in India?
I've said, well, I'm so I was with analogic and analog devices, and I've seen the kind of things we could make and how they were used, how they were programmed, from electric meters to panel meters to control system. And the real problem limitation is the ability for average technician, engineer to program it, reprogram it, figure out what to do when they fail. So with a major problem with IoT is that when there is a failure, what is the limp back position? What will happen? Can you predict what will happen? And then how fast can you fix it? So very often to have a fail-safe or system that you can maintain, IoT moves you in a wrong direction. In terms of practical experience, my son went with this. I've trained my children to be, do this kind of thing, so they did. And the guests could not figure out how to use it. And when they had to, when the router had to be updated, application had to be updated, the lights didn't work right. And we finally, when he sold his house, he had to spend enough time making sure the new owner will be able to sustain it. So yeah, I would not install IoT in my house.
Okay, thank you. Yeah, I was in India recently, and someone staying in a fancy, very nice hotel complained afterwards when I went to pick them up that the technology was so sophisticated they couldn't figure out how to turn on the lights, just as you're saying, in the hotel room. Yeah, so there may be some learning from users that is a prerequisite for making this work. Nazir? Unmute, please.
I think Vinod's is a more interesting general viewpoint, and I think it does require scale. And if we're going to be getting there, And what he's saying is that these things are coming together. To just give you one example, Toyota has plans to do away with the assembly line. The motors, that they're making will first have, the EV, the batteries and all that installed, and they'll be able to move themselves along without any kind of track. So, you're going to have, what I'm saying is, the point that Vinod's trying to make, and what I understood, is that there's a lot of things that are happening that are going to change manufacturing and a lot of things dramatically in the next 10, 15 years. Is that correct, Vinod? I mean, and that was the main takeaway that I got of that, plus large data sets, refining, improving it constantly. I think, you're going to get radical improvements in things.
Yeah, I mean,
I found more or less the medical kind of field, the health field, and there you can see a lot of changes occurring because of convergence of different technologies. And it's
yeah,
the convergence that
anytime there is new technology, there will be opposition and will take time for people to learn. And you're very right. I mean, Hasmukh is very right that you really need a lot of training and so on. I mean, I remember in the 60s, I don't want to tell you how old I am. In the 60s, when I studied at the Indian Statistical Institute in Calcutta, there were riots there. Why are you bringing computers? You lose a lot of manpower. There were riots there, really. And look at it. Today, nobody can do without a computer. We carry a computer in our pocket. I think these are people who are not used to it. Regarding the smart home, I mean, I don't think I can handle a smart home myself. And that is one of the reasons I didn't try it. But we do have many smart equipment at our home. In fact, the refrigerator I bought last year is a connected refrigerator. I never connected it because I don't want it to order milk for me. So technology takes time for people to learn, to understand. And I do think, unlike what Hasmukh said, it is a game changer. I mean, when the CNC machines came in the 80s, they were a game changer. I would say the same sort of thing today. And it's not just today, it's for the last several years been going on. IIoT is really a game changer. Okay.
Yeah, next question from Ganesh, Professor Ganesh Krishnamurthy, a colleague in the accounting group. Ganesh, are you there?
Yeah, thanks, Ravi, and thanks, Vinod. Interesting presentation. As Ravi mentioned, my background is in accounting, so I certainly learned a lot with respect to IIoTs. But one thought I had, I mean, I had a question on leasing, but I'm not going to go there. I have actually a different question. Is how do you see, as these devices become more intelligent and more AI embedded in them, do you see that as the IIoT 5.0? I'm sort of reminded in some way, there's actually a very interesting book. I'm not sure if you've gotten a chance to see it. It's called Life 3.0 by an MIT professor called Max Tegmark. And he talks about like when the evolution of Internet of Things and when more AI is embedded in them, that you have all kinds of issues, both ethical and otherwise. An example he provides is like iPhone, which is an example of IoT that you provided. But when you have an AI built into it, whereby, let's say, for example, the iPhone is able to detect that you just broke up with your boyfriend or girlfriend and starts playing, music accordingly, or starts suggesting some products associated with that, that takes the IoTs to a completely different kind of realm. And from there, we have a lot of issues, including things like cybersecurity, privacy, which you may be addressing in your book, but didn't probably get a chance to cover in your presentation. My overall question is really, where do you see this all going? Because most of the examples that you gave were very good, but they were not things that I would have imagined. Those are things I would imagine can be done without really the influx of all of the AI, generative AI, and all of the other applications. So where do you see this going in the next 5-10 years? And is something like what Max Tegmark is looking at, is that the next wave? Is that what we should be expecting? So I'll stop there.
Yeah. I mean, I think it will continue to grow substantially. But you're very right. There are ethical issues involved, especially with regard to AI. I have, for the last couple of months, I've been trying Chat GPT. And I learned that a lawyer presented 2 cases to the judge and was fined $5,000 because those cases never existed. He just took them from Chat GPT. So it can provide wrong information. And ethical issues will be there, I'm sure. And I don't know what else to say about this, but I'm very excited and very hopeful for this technology in our personal lives and in the industry.
Yep. Don, if you could just introduce yourself, because we haven't met before, and then ask your question.
Oh, hi, professors. I'm Dawn Ling. I am a part-time MBA student. I was actually just adding on a follow-up comment to this situation, especially in IoT, about how we had a situation with smart light bulbs. It wasn't really a question, just supporting Professor Jain's point. So thank you.
Thank you.
Okay. Anybody else have a question? I think I've seen all the questions on chat. Som, are you about to ask a question? I can tell. So,
Som and I have a private conversation occasionally.
Sorry?
Som and I have a private conversation occasionally.
Okay. How about Ipek? I hope I haven't mispronounced your name.
Yes, Ipek. So I was just saying that it was a wonderful presentation. Thank you for the valuable insights. And I'll be running to another department meeting. So thank you.
Introduce yourself, Ipek. We haven't met.
Yes, I'm actually at Bentley University. I'm an assistant professor in the management department. And, you know, I'm interested in international business research. You know, that's why I just wanted to check the events here. Yeah, that's how I.
Terrific.
Yeah.
Yeah, thank you for coming, and come back to our future events as well.
I will. Thank you so much. Have a great day.
Thank you. So I want to go back, circle back to, I think Subhash raised the question, Vinod, which is taking us back to sort of the academic perspective. Certainly, you've designed this as a practitioner book and presented it as a practitioner-oriented talk. But what are the implications? And maybe you covered it in the book. I remember reading through many chapters, but don't recall all the content right now. What are the theoretical implications of these developments for strategy? Are there any that you can pull out, that this kind of connectivity and the intelligence put into the hardware and across the entire value chain? So it's not just in production anymore, it's all the way from, you know, sourcing to production to distribution to end user, and, you know, data is being collected on all of this. Does this conceptually have any implication for what strategy means or how we teach it?
It's a big implication. I mean, just to get you excited, I recently looked at the MBA capstone strategy course syllabus at the top 6 universities in the world. Now, this is 2 years old. None of them had the word digital in them. Okay, first. Second, as I started saying, there are three kinds of products: physical, digital, and Internet of Things. Much of we teach in strategy is for physical products. Michael Porter's theories work for industries that are stable, not growing like industries today are growing. I know he has, even 2006, he wrote an article, Strategy and the Internet, but I'm really convinced that he needs to update his stuff. I'm saying that because I know Michael Porter and have taught his courses for a long time. So I think from the teaching perspective, we really need to update our courses, not just with physical products. Now the digital products and the IoTs are growing exponentially in the world. And a lot of in international trade, I mean, there is just so much going on, data exports and so on. So we really need to start incorporating these things in our curricula. I did a seminar, a webinar for Academy of Management last year on this theme, which I think was really attended by a lot of people. So if it made any impact or not. Now, not just teaching, I'm sure a lot of people are now thinking of these new research opportunities with the digital models and so on.
I agree. You're absolutely right. We need to incorporate digital and the what you call the digital meets physical into our courses that we teach.
Right.
Conceptually, I'm thinking about what this might mean, for instance, to the blurring of industry boundaries, as we used to think of them. But when you have this technology that goes right across everything in the value chain, it may disrupt or blur the boundaries, as we're seeing with some of these companies. Amazon is in so many different areas. It got into cloud because it was using that as part of its to meet its own needs, and then decided to make it available as a product to others.
Exactly.
And so then it gets into a very different business. It's now getting into physical logistics with trucking, and companies like FedEx and UPS are wondering if Amazon is a customer or a competitor. So this blurring of the boundaries, and I don't know if digital is contributing to that. But we have just a few minutes left. I want to ask if you have also looked at the potential for all of these applications you're talking about in the government sector, because you looked at B2C and you looked at B2B. But there's also the B2G or the G2C or C2G, as you, depending how you want to look at it. In many countries, governments, like in India in particular, for instance, is really trying to use digital as a way to modernize the government sector. And it also helps to not only take out cost, but also improves transparency, has the potential to reduce corruption, and so on. So have you looked at e-governance and the application of any of these technologies in that sphere?
I have not really looked at it, but I can visualize a great opportunity. India specifically, just the introduction of the Aadhaar card has done wonders in terms of removing some of the bad things that go on through government funding. I've not really studied this.
Okay. Maybe in the next edition of your book, you can add a chapter on this.
Yeah, there are chapters to be added.
Yeah.
There's just so much happening.
Right. It's very hard. Thank you for pulling together all the things that you pulled together, because it's hard. It's like drinking from a fire hose, as they say. The developments are moving so rapidly. Yeah. It's hard to keep abreast. So thank you for pulling these things together for us today. And our time is almost up. So I want to thank you, Vinod, for
thank you.
The book. and also for sharing your insights from that project with us. Let me thank also the audience who've joined us today, and Catherine for organizing the seminar. Finally, I just want to say for those who are here that we have a few other events coming up in the next few weeks. You could see that on our website. We have other speakers in the Nardone seminar series, but two in particular that coming up in October that I want to flag. One is we have the CEO of FedEx, Raj Subramaniam, going to visit Northeastern at the Center for Emerging Markets and talk about digital first FedEx. So really ties into what you brought up here is really the central part of what they want to emphasize. And as you know, as someone in the chat observed that FedEx was already doing a lot of this digital, meets physical, with the tracking system. They're one of the pioneers in that area. If you remember, very early on, they were one of the first where you could actually see your package moving from, when you dropped it off to its final destination, and you could see what was actually received and so on. So, but the world is moving very rapidly, and I think they're looking to move the digital further within the company. So I think that would be of interest to all of you who've attended this talk. And then on October 28th, we have a summit, India Summit, focused on the Indian startup landscape. And I encourage you, all those who can, to attend in person or to watch the live stream. Because again, as I'm sure many of you know, a lot of the startups in India are in the digital sphere. The unicorns, India has produced 108 unicorns, and many of them, most of them are digital businesses. So they're all contributing in different ways to this digital meets physical theme that Vinod has presented to us today. So Vinod, thanks for getting the ball rolling on our Nardone seminar series for this academic year.
Thank you.
And look forward to seeing all of you in future events. Thank you all, and goodbye.
Thank you, Ravi. Thank you, participants, and pleasure being here.
Thank you.
Thank you.